For the next part of the write-up, what we're going to do for the oscilloscope and function generator. Oh, there it is. Okay, part 2, oscilloscope and function generator. We're going to use the oscilloscope and the function generator. And so what we're going to do is to try to connect the function generator directly to the oscilloscope and measure the signals that are listed there. Your write-up or what you're asked to display may be somewhat different than this. So I'm just doing what we did last fall, and we'll see how that works. Now I've got the function generator turned off. You notice I disconnected everything from the power supply. There's nothing connected to the breadboard. So what I'm going to do is to go and get the cables. These are called BNC type connectors. Okay, I'm not sure why. You can probably Google it. There's probably a good explanation, but they're called BNC. They're locking twist-on type connectors. So you need the right cable for that. And so the cable that we want for this connection is going to be over here on the cable rack, and this is the type of end that you want. But the other end is important too, because you're going to need to connect this into the into the other cable. So try to get some ends that look a little bit like this, if you can, and take this cable off the rack, bring it over. And let me show you how these twist-ons work. The output we're going to use is the one called main, and so what you're going to do, there's a little slot there, and there's a little burr, I guess you'd call it, on the jack. So what you need to do is line those up and then push in. You have to hold the instrument with one hand, so I have to do this off camera. It's kind of springy. You twist. Sorry, my camera went out of focus. But anyway, so there is that twist lock, and to take it off, you do the same thing. You twist it and pull. So you'll get familiar with that. Now we're going to take the other end and connect it to the oscilloscope. And we're going to just use one channel of the oscilloscope right now. We're going to use channel 1. And I just had to untangle these, but what you want is this channel, this cable. All right. Now, the oscilloscope cable has ground and signal. You want signal connected to, these are both spring clips, so there's no way I'm going to be able to do this with one hand, but I'm going to tell you I'm connecting these two together, okay? So do this off camera very briefly. Okay, they're both spring clipped together. And then the grounds are going to connect together. So I'm going to connect these two together. And I'll have to do that off camera as well. All right. So those are connected. That's connected. And now what I'm going to do is to turn on the power supply. And when I do that, not the power supply, I'm sorry, the function generator. But when I do that, then you'll also be able to see probably some signals show up on the oscilloscope. Okay, so we now have something new on the oscilloscope. Let's see what happens. Let's see what happens here if I increase the frequency. All right. So this is showing 33 hertz. And this is showing a sine wave. Now what would happen if I change the wave shape down here? So maybe I can change it to a square wave, or a triangle wave, or a sawtooth. notice on the oscilloscope itself is actually measuring that signal and giving us a readout. It says 33 point something hertz, okay, 33.7 roughly. Well, that very, very closely matches the display that's on the signal generator, as it should. It's the same signal. So the function generator is telling you what it thinks it's putting out, and the oscilloscope is telling you what it's receiving. So that's very handy, and you can use those measurement buttons in order to record whatever you need to. For example, one of the waveforms that you're supposed to record is a 1 kilohertz sine wave with 2 volts peak to peak. Now I'm going to turn off channel 2 because we're not using it, so I'm just going to push the channel 2 button, and that gets rid of the blue trace. And I want to also show you that you can move that trace anywhere on the screen that's convenient for you. So you can just turn this knob and you can zero that. If you look over here, you will see a little arrow that's pointing, that's the 0 reference. Okay, so if you want to line that right up with the midline of the screen, that gives you a better idea of what's going on with that waveform. Now that waveform is going equally positive and negative, so it's what we call a bipolar waveform. If I turn this to sine, so I turn the function generator to the sine position, and then I'm going to adjust the frequency down here. So I want to be in the 1K range. Again, 1K stands for 1,000. I want to be in the 1K range. It's a little bit hard to see, but the kilohertz light lit up. So whatever is showing up on the display is now times 1,000. So I want to turn this down to 1. And it doesn't have to be exact. Just get as close as you reasonably can. It doesn't have to be exact. Okay, so this is 1.003 kilohertz. But look what happened to the display. Now it's a big muddle. It's a big mess. And the reason is because the peaks are so close together that you can't see them. So there are a couple of ways to fix that problem. One of them is to come over here to this scale button. This whole panel right here is for the horizontal display. So if I turn that button, you can see that it changes the timeline, and so I can get a better view. It's like zooming in. Okay. There's another way that you can do this. That's very helpful sometimes. There's a magic button on this scope called auto set. If you hit auto set, a lot of times it will figure out for you the best setting, and it will show you what you want to see on the screen. All right, now you can see it's pretty big, and the bottom of this is going off the screen. So there's another setting, which is the scale setting right here. That's the vertical zoom. So this is the vertical zoom, this is the horizontal zoom. Get your waveform set up so it looks nice on the screen, and then you can take your readings. Now, we already looked at the frequency reading. There's something called the cycle RMS, but there's also the peak to peak over here. And this peak to peak says 7.2. Well, in the chart, it asks for 2 volts peak to peak. So how do you adjust that? Well, now you come back over to the frequency generator, the function generator, and I use those words interchangeably, and you adjust the amplitude. And when you adjust that amplitude knob, you can see the waveform get smaller. And you can adjust this until it gets all the way down to 2. All right. I thought I got lucky there. Now you're not going to get it exactly at 2. Just get as close as you can, and that's fine. And then come back and zoom in as much as you reasonably can. And one reason for doing that is that the computer in the oscilloscope actually looks at what you're seeing on the screen to make its measurements. So the bigger that signal is, but still fits on the screen, the more precise your reading is going to be. So you can now read the peak-to-peak value. Now, the numbers, the measurements that are shown on the screen are adjustable by you. If you need to see something that's not on the screen, then what you can do is to come over and hit the measurement button. And then you'll get a soft menu over here. You can hit channel 1. And then you can use this knob, this multi-purpose selection knob, to highlight whatever measurement you would like to see. So mean is the same as average. So you can see all these different things, but whatever is currently displayed is highlighted here. All right. Now, if you're done with that menu, you can make your selection by pushing this button. I'm not going to make any changes. Then come down here and hit this to get rid of the various menu levels. Okay, so that's how you make those measurements, and try that with the different wave shapes that are indicated in your lab. So I'm going to end this segment, and we'll do another one for the next part of the lab.